Now, the oscillations basically are the reasons behind vibrations, right? Whenever a object or a particle is going to possess oscillating motion, that will cause the vibration of the bodies, right? So also we know that the elastic properties of the different objects or the particles are responsible for these kind of vibrations. Okay, so first we'll start with the reasons for vibrations, right? So this is the oscillating motion of the elastic bodies, right? So they are the very basic reason behind them, right? So there is what is called as oscillatory motion. So motion, the path of motion is going to be repeated. So they are going to repeat the path which they follow. And also uh, all bodies which possess mass elasticity are actually causing the vibration, right? So oscillatory motion, this is of elastic bodies. This is due to the mass and elastic properties of, right, of any object. So the basic feature of oscillation is called as periodicity. So what is periodicity? It is going to the movement or displacement or the variation of a physical quantity will repeat again and again, right? So here we can see that the movement or the displacement, right, repeats again and again. That's what is the basic reason behind vibration, right? So this particular concept is applicable for mechanical systems, for electronic system, right? And even for the micro or nano level physics, we can see that the light is made up of, right, particles which oscillate when they travel, right? Electric and magnetic fields are responsible for that. And also we have seen the examples like sound, right, is also a periodic motion of atoms and the molecules, etc. So everything what we have studied in basics, they correspond to uh, the vibrations only. Okay, so periodic movement of the particles, right, is what we call as the vibration. Now, so let's look at the types of vibration. So basically three types of vibrations do exist. The first one is called as it's free vibration, and the second one is called as damped vibrations, and we have the third technique called, this is forced vibrations. Let's look at the types one by one in detail. So we'll start with the free vibrations. Okay, now to define the vibration in which the body vibrates with its own frequency called the natural frequency when left free to itself without decreasing the amplitude. So whatever is the oscillating amplitude, the magnitude of oscillation, it remains same throughout without any change at any point of time. Okay, so let's define this. So free vibration is nothing but the vibration, the vibration in which the body vibrates, with its natural frequency, when left free. So whenever we leave it free, it oscillates, right, with its natural frequency. And second feature is that without decreasing the amplitude. Decrease in its amplitude is called as, right, called as the free vibration. All right, so in case of a free vibration, there is a restoring force that acts on the body, and this restoring force is always proportional to the displacement, right? And always the force is acting towards its center of oscillation, right? So in case of a free vibration, so there will be always a restoring force, and it is always proportional to the displacement of that object. Okay, in the sense, how much is the displacement from the mean position, right? That much is the restoring force. As you move away from the center position, you have more and more force acting on the body to bring it towards the central point. Okay, so this is very we can see the same thing happening in case of a simple pendulum or a spring mass system, right? So you release the pendulum. As the pendulum moves further and further away from its central position, you see more and more force acting on it, right, which tries to bring it to the other side, but it overshoots on the other side because of the extra force. So like that, it keeps on oscillating, but that is not a free vibration, because over a long period of time it will come to rest ultimately. Okay, so now our intention is to analyze this uh, technique, the free vibration. Let us try to analyze this in detail. Okay, so this is the mathematical analysis of the free vibration. So let us assume that there is a particle of certain mass m. Okay, so let m be the mass of a particle, right, acted upon by a restoring force proportional to the displacement. So the restoring force can be expressed as a let's try to write this. Okay, so let the restoring force, let this restoring force is equal to minus mu into y. Okay, so here mu is what is called as proportionality constant. So y is the axis of vibration, right? Axis of vibration, or this is also the displacement along y-axis. So along y-axis, how much the particle is moving, right? That's what is denoted by y. And it is a negative sign, right? Because it is always opposite to the direction of displacement. So here, negative sign indicates, right? This indicates that the restoring force, acts opposite to that of the direction of the displacement. So whatever is the displacement, force is acting in a direction which is the reverse of that. So what we do here, the force, because we are trying to write a force, so we know that, right, the force is mass into acceleration, correct? So that is, this force is equal to mass m is the mass of the object, we assume, and if y is the displacement, dy by dt is the velocity, and the d square y by dt square is the acceleration. So this is the force, okay? But also we know that just now we denoted the force by minus mu into y. So force, this is equal to F. All right. So that means both of them have to be equal, right? So, okay, let me make this as equation number 2 and the previous equation as equation number 1 so that we can equate them easily. So this is 2 and let's say this is equation number 1. So both of them have to be equal now. So because of that, equation 1 should be equal to equation 2. This implies, let's write m d square y by dt square is equal to minus of mu into y. Alright, now what we do, we'll write d square y by dt square is equal to negative, this is mu divided by mass into y. Okay, now we'll make a substitution. We'll call omega square is equal to the mu by m. Right, we'll bring a squared term over there. That's why we want a omega square. This could be later on, we'll see that this is the angular frequency. Okay, so this implies we update d square y by dt square is okay, I'll bring the term to this. Okay, first let's write the same thing. This is minus of omega square into y, right? And bring the omega square y to this side. So this is going to generate d square y by dt square plus omega square y is equal to 0. Right? Now I can see that this whole function is a second order homogeneous differential equation. So we know that, right? In mathematics we have studied how to solve the differential equations. Okay, so that means it will be of the following type. So what is the type of this? Actually, if you remember, we have to go for a complementary solution first. Since the RHS is 0, there is no YP, only YC will be calculated and we'll write the answer. So that procedure we can follow otherwise. So let me give an equation number to this. So this is say equation 3, right? So solution of 3, equation 3 is in the following form, right? So it is always e to the power something, right? You get a root as alpha, and that is what we write is in the following form. Y is equal to e to the power, say this is alpha into t. So let's call this as 4, right? So what is dy by dt? Because I need d square by d square y by dt square. So dy by dt should be equal to, differentiate the equation 4, it gives alpha into e to the power alpha t. Okay, then I need d square y by dt square to substitute. That's why this becomes alpha square into e to the power alpha t. All right, so let us try to substitute this back in the given equation. That is the previous equation, equation number 3. So we will substitute. See, there is a d square y by dt square and omega square into y. So that we can substitute from these two. So this is equation 5. Put 5 in 3. So you can see that in the original equation there is a d square y by dt square. But just now I have calculated that d square y by dt square is nothing but alpha square into e to the power alpha t. And the second term there is a omega square into, this is y. So y is in the form e to the alpha t, we assumed. This has to be equal to 0. So you can see that e to the alpha t into, this is alpha square plus omega square equal to 0. So we know that e to the power will not become equal to 0 because, right, if that itself is 0, then I don't have any other answer, right? So we can say that since e to the alpha t cannot be equal to 0, right? What is the other option? This implies alpha square plus omega square has to be equal to 0. Okay, so this implies, let's calculate the alpha now. So this means alpha square is equal to plus or minus omega square. Not plus or minus, my mistake. So this has to be simply minus omega square because the term going to other side is negative. Okay, so alpha square is minus omega square. So alpha should be equal to, there is a root of negative, so this is denoted by j. I have plus or minus, right, omega, because omega square root is omega. I have two roots now, right? Now you see the general format. Therefore the general solution y is equal to, so a constant, so a1 e to the power first root is j omega t, right, plus another constant a2 e to the power minus j omega into t. Okay, so let's call this as equation number 6. So if you remember what we did in mathematics, that's also very similar steps. We used to call that as complementary solution, get the roots of the equation and write. So even in that case, you used to get the similar format as the answer. So here we are supposed to mention that where a1 comma a2 are constants. Okay, now since it is e to the power j theta, there is an identity in complex numbers. If you have e to the j theta, this can be written as cos theta plus this is j into sine theta. At the same time, if you have e to the minus j theta, this should be written as cos theta minus j times sin theta. Okay, so let's just remember that there is a property like this. So now let us apply this to equation number 6. So this implies, so equation number 6 becomes y is equal to, there is a constant a1 outside, it remains as it is. See, e to the power j theta, I can see that theta is omega t, so it has to be, this is cos of omega t plus j into sine of omega t. This is the first term, e to the j omega t, I am replacing like this. Then plus a2 into, it is cos omega t minus, because it is e to the power minus j omega t, minus, this is j into sine of omega t. Alright, so this is the term. Okay, now let us try to club them together like this. So this is equal to, I'll write cos omega t is common, so I can write a1 plus a2 times cos omega t, and the second term is, I can say plus j is common between the sine terms, so j, I can see that a1 minus a2, so this is a1 minus a2 into sine of omega t. Okay, now whenever we have say two coefficients like a1 plus a2 and a1 minus a2, right, this could be related to a function such as, let's denote like this, a1 minus a2 I'm going to call in terms of a angle, this also I'm trying to represent in terms of an angle. So let me assume that a1 plus a2 is another constant a into say sine of an angle phi, and the other term a1 minus a2, let's assume that this is a cos phi. So this means if you make an assumption like this, the above equation y is equal to, it changes now. So the first part is, this is a sine phi into cos of omega t plus, so this whole term including the j, okay, so j times a1 minus a2, I'm going to call it as a cos phi, so that becomes a cos phi into sine of omega t. So this looks like, right, we have another function here, that is, we use a trigonometric identity to simplify this. Let's write, this is sine a cos b plus cos a sine b. If you find something like this, this can be directly replaced as sine of a plus b. Okay, let's remember this particular formula. Okay, so whenever I am trying to use this, right, I should be able to apply that. So you see that this, the a looks like this is sine a cos b, cos a sine b. So this means the a looks like phi for us and b looks like omega t for us, correct? So I can write, therefore y is equal to, this y will take the following format. A is a constant that is there for both the terms, so sine a cos b plus cos a sine b is, this is sine of a plus b, so I'll write it as omega t plus phi, right? So this represents the displacement of the body in a free vibration. A is the maximum displacement. So this is the required equation, right, where capital A is the maximum maximum possible displacement. Okay, this is also called as amplitude of the vibration. Now, at any given point of time, right, we can definitely write this as, right, at any given point of time t, right, we can actually make changes in this. So t is equal to, let's write that point now. So the value of y is going to repeats when the t is increased by a specific value. Okay, and the value is denoted like this. So this value is increased by, let us say, 2 pi divided by omega, right? Whenever this is increased by this value, we will see what happens. So this implies, let's say, y is equal to, this is a into sine of omega. There is a t should be t plus 2 pi by omega, right, plus phi. So we can write this as, this is still equal to sine of omega t plus 2 pi plus phi. So sine of any angle plus 2 pi is still same. So this is, I can still write this as a into sine of omega t plus phi. So the indication is that your value will not change. That's why this value of t is called as period of oscillation or vibration. So therefore capital T is equal to 2 pi by omega is called as the period of vibrations. Okay, and the frequency f can be calculated as omega by 2 pi. This is nothing but 1 by t. These are the important equations. So if the a is not going to change, then we are going to call this as, right, the free vibration.